Very welcome. My name is Sahar Tahvili. Currently, I'm acting as the head of the validation and verification at Einride, which is a scale-up company in Sweden focusing on autonomous vehicles. And I'm also adjunct associate professor in AI industrial system at Mälardalen University in Sweden. A bit about me. I have background in applied mathematics. I studied master and bachelor in applied mathematics, and during the PhD, I worked as an industrial PhD student at Bombardier Transportation and Research Institute of Sweden, and I was enrolled at Mälardalen University, and then I started my career as a senior data scientist, senior researcher, and then changed to management for how we can manage AI, how we can have AI in the reality, and how we can have better AI for the future at industry. So, like all other researchers, I have a lot of publications, patents, books, but I selected those two books today, and there's a reason behind that. The first book, Artificial Intelligence Method for Optimization of the Software Testing Processes. I'm a co-author of that with a good colleague of mine, Leo Hatvani, who's from Sarajevo. So somehow our book is half Bosnian. So it would be nice to present it at home. And second one is a book chapter that is about software development process in general, and one chapter we wrote about how we can use AI in the testing processes. So until now, I can say I can divide my career in two passes: how we can test the AI algorithm and how we can use the AI algorithm for testing. And as an adjunct associate professor, I'm affiliated at university, working with the students, new generation, and doing some guest lecturing or mostly acting as an industrial supervisor. So today's presentation is a slice of my life, how I divide my career in two different passes, and challenges, opportunities, and how we can go to the next step. Before I go to the details about two industrial use cases that I try to present today, and also the challenges, as an abstract and summary of the gap and differences between AI in the lab and in the reality, I mean in the industry and at university, so I can go to those points. So in the university and research is like the AI, when we are talking AI, mostly we are talking about the accuracy. Comparing the performance, coming new algorithm, presenting them, and showing in a very clean environment that everything works perfectly, and there is just a competition to show my algorithm is better, and that is F score, that is accuracy that I have. So it's a controlled condition, say, and there is not so much challenges. Of course, sometimes some researchers like myself working closely with industry, but generally big differences we have, and mostly is in the data size, data type, and what problem we are trying to solve. When it comes to industry, most of the time is the decision and discussion is about the money. Can we make more money? Why we should go for AI? And it makes sense to change the procedure, manual way of working. We should talk with the team and how we can do it in a better way. The data usually, when we have at industry, is messy, incomplete, sometimes it's just knowledge, sometimes it's not even data, it's information. It can be in people's mind, it can be in some messy document here and there, and the way of working that we translate this knowledge and information to data and later machine-readable data is big work. Before we jump to the algorithm, before we jump to accuracy and showing it works, this data gathering by itself is a messy process. And sometimes it takes a lot of time, and it's like in the end, okay, let's do it in the meeting. Let's solve the problem in the meeting. We spend less time if you compare to going to AI. And the regulation, especially when you are running in the European Union countries like Sweden, GDPR, a lot of restrictions, a lot of regulations, security, a lot of things coming to the table. And finding the balance between the effort and the gain is the challenge. So whenever I'm at university, it's like students, researchers, they are very happy about the new algorithm, new solution, and they're trying to convince industry, let's use it. But whenever I'm at industry, it's completely other way around. How much we can gain and why we should go to the new way of working. So we wrote an article in IEEE Software, me and a colleague of mine, Marcus Bori, about those challenges. So I recommend you to read it, and it's like some idea of this presentation somehow. When I'm at university and checking with the students that we have a problem for scheduling, let's solve it. And that is the data that we have from industry. And I'm ending up to seeing deep neural network TensorFlow for solving rather simple problem. And whenever I'm asking why we are going for that, this problem needs to be solved fast, effortless, and cheap, and why you are going for a heavy AI model. And the answer is like, if a linear regression model can solve this, why TensorFlow came up? So I'm always saying, yeah, if the USA is so great, why we went to USB? So it's like you're comparing USA and USB in that sense. So finding a correct algorithm, a correct AI model for solving a problem is a challenge, both at industry and academia. And academia is like why we should go for the traditional way of working, traditional research, traditional algorithm, and why we are not going to the next step without checking what is the effort that we need to put if we would like to use it in the reality. One thing that I'm always saying to my student is not all the intelligence is smart. So still some of the old-fashioned methods, we can get not maybe better results in the sense of accuracy, but is easier to use and is effortless to use at industry. When it comes to industry, now is another side of the game. Convincing people to not using Excel. For instance, very super complex problem that I will present later in the slides, that we came out with the reinforcement learning, deep reinforcement learning solution as the best solution for getting the correct answer. And I got it from colleagues that, but we are solving this problem with Excel. Why we need to go for AI? For Excel, we don't need to do onboarding, we don't need to use manpower, we don't need to use, computational computer. We can run it on the computer, we can have it on our phone, and it works. Well, somehow it's correct, but even manual way of working has footprint, has carbon footprint, right? For some of the tasks, which is routine, which you need to do every day, or you need to sit in the meetings, after meetings, with a big team, it's better, faster, and easier, and much more efficient to use AI. And always I'm saying to the colleagues at industry, Excel is just a tool. It's not a way of working, it's not a strategy, and it's not a process. But why there is such a resistance for using? People are afraid to losing job. You need to learn new skill and other things. And it's not easy task to sitting with them and convincing them that is the new, that is the revolution. We should go to the next step somehow. Of course, not directly. Still, we have human in the loop. Still, we need your input. But it's the end of those way of working, manual way of working, and meetings after meetings. So finding the balance, as I said, is very tough in both sides. Before we start writing our book in 2022, we decided to do some study mapping. Where are we now? And we check it since 2017. What is the adaptation of AI at industry, academia, and what's going on? So you can see it's up and down, especially at industry, just because COVID happened and a lot of things, cost always, business as usual. So other things impact the technology, even politics impacts the technology. So it's up and down, but at research, just because it's like if you have enough money to pay just one PhD student and you can define thousands thesis worker, then you can do the research on the AI, so no one will stop you. But meanwhile, with big game-changing by OpenAI, everything is changed. After we published our book, it was in the beginning of the coming AI in everyone's table, And it was ChatGPT, first phase, that OpenAI did it, and then everyone realized, oh, there is something, so let's do it. Now, everyone would like to have AI now, as I said, for solving a rather simple problem that can be solved really with Excel or linear regression. They would love to jump to generative AI. And before that, it was we trying to say some of the tasks can be done by AI. And now a lot of terminology are mixed up today. It's like automation is AI. It means AI today. AI means AI today. Machine learning means AI today. And usage of generative AI after this revolution going up. And let's see how will be this figure in 5 years. But for our book, the pre-study of our book, me and Leo, we thought, okay, let's check what is the percentage of human involvement versus AI when it comes to the software development life cycles. Different steps, more important steps, how we can have human, how we have human and people today, human and AI today. And you can see in some of the aspects we have more involvement of AI, and in some of the aspects we have less. And don't forget that is before 2022, the time that we try to summarize our proposal for the book. When it comes to the testing, which is our domain, so we saw good involvement of AI, interesting. And then we try to break it down, what it means exactly in the reality. In what aspect of software testing we have more involvement, and in what phases of software testing we have less involvement of AI. And that is the results. Requirement analysis, test planning, less AI. Test process optimization, less AI. Execution analysis, prioritization, development, more AI. Any clue why this figure is like that? For instance, why in execution analysis we have more AI, and in requirements analysis we have less? Any clue? Sorry? Data type. Data type is the one of the answer. When we are talking about execution analysis, the data type is like log files. It's already a machine-readable data. Is easier, the data which generates by machine, easier can be read by another machine. So the data type, data size impacts a lot the involvement of AI. When it comes to aspects such as requirement analysis, what is the data type? Text, written by people in different level of the language, different understanding of the requirements, even different languages is like not same. Even it's the same, for instance, if all of them are in English, when you are trying to read them as a human, it's hard to understand some of them, even they are talking about same thing. When it's hard for us to understand, so it will be hard for machine to understand just because machine needs our help to translate this data or make data from this information. Other aspects like test process optimization requires soft skill, human skill, decision making. A lot of the challenges with the stakeholders, with the customers, still we are solving in the meeting, in the coffee break, right? Not necessary by the Excel, not necessary by any other tool. Soft skill is required for that. So that's why we see less involvement of AI. That was the point that me and Leo, we thought, okay, let's focus on those aspects that we see less involvement of AI. Our colleagues can work on the other things, and they are doing, and let's do on those aspects that is less involvement. So that's why our book is mostly about natural language processing, how requirements can be translated to machine-readable data, which calls vectorization. You can have a vector, which is a matrix, numeric matrix for a text, for a paragraph or entire document. And whenever you translate something as a vector, as a matrix, then different AI model can read it, and you can do whatever you want it. You can cluster them, you can classify them, you can reduce them, you can find the semantic similarity between them, you can find redundancy, anomaly detection, and whatever is needed, and you can optimize the process. But before that, it will be a bunch of documents in the Google Drive here and there, and it's very hard to use it with AI in the reality. So that's why our book is mostly about that, how you can do this process, how you can optimize the testing processes by using different natural language processing. And code translation as well. So vectorization can be for text to vector or code to vector, that you can find the similarities, the redundancy, dependencies between codes as well. Backing to the issue of AI and human involvement. At industry, usually, people are happy to use AI or whatever you call it, automation, when it comes to the repetitive and routine tasks. No one is happy to do the same thing every day. So then you have more chance to introduce AI, machine learning, or any kind of automation. When it comes to the large-scale data, if you have it, the messy data, the data that you need to gather from thousands of different sources, then people are happy to use AI, and no one will complain why you are going for AI. In the management point of view, whenever we would like to do predict analysis and doing optimization or saying that will be, for instance, our cost, that is the forecast, those things, they would love to see a bit machine and AI behind that rather than human judgment. But still we have human in the loop. It's not something that we do just by AI and presenting to the company. And when it comes to the testing, which is my domain, deployment, automation is good place that you can touch it and you can say, here I have some solution for solving the process. But other way around, when it comes to the human, we have some points that is both hard to introduce AI, or will be a lot of discussion. People are not happy. Complex decision making. It's very nice that you have some clue from AI, but still, whenever it's required, soft skills, negotiations, those things, still is better or is easier or faster to have human in the loop or human decision making. Ethical in Europe, so it's not easy that you make some decisions by machine and present it. Still, it should be human decision making. And high-level project management. Of course, you can get some prediction with AI, but when it comes to the decision-making, it will be human making the final decision. Backing to the software testing, what will be the risk if we are not using AI? Or we don't need to go 100% for AI, as I said, but still AI as assistant or AI-based solution, but human-centric. All the things that we are doing in software testing is time and resource-consuming manual process. Of course, it depends on the size of the product and the maturity of the company, the maturity of the product, which phase of software testing we are talking about. If we are in the beginning, where the product is not mature, where the test environment is not ready, then it will be very time-consuming if you would like to solve the problem manually, which means assigning the test cases on the test track for execution, or writing test cases based on the requirements, or writing requirements based on ISO standards. Requirements requires deep knowledge in the domain. In my team, we need different skills. It's not enough with having just one tester or two testers, one test manager. You should know the domain. Or we are talking about safety critical system, or we are talking about telecommunication, and then we need to have AI skill as well. So it's a mix of different skills that you can have it as people in your team, of course, but when it comes to automation and you would love to go to the next phase, having AI can help you to reduce this heavy knowledge in the domain just by one person. You can't force someone that you should master all the ISO standards. In safety critical system, you should know testing methodology, you should know test automation. It's very hard. Then a big team needed. and can't handle larger scale. When the product goes to the next phase and we have more features that need to be tested, then the number of requests that we get is increasing daily. So the number of requests for the test cases or the number of requests for the test environment. We have a limited number of test environments, and everyone wants to test the feature as soon as possible. So how we can solve it? One aspect that we've worked a lot, and it helps us to reduce unnecessary failure and, of course, cost, is the dependencies between test cases. When it comes to the testing, you need to have a scenario for testing a feature. Those scenarios are not necessarily completely independent, that you can run them whenever you want it. Sometimes there is dependency between them, and you should take care of the dependency. This scenario, which means this test case, should be executed first, and based on the result of this test case, the next one can be selected. And if you are not paying attention to such a dependency, we are going to get failure after failure after execution without finding any bug in the system. So it's just waste of resources. You do the testing, you get failure, but there's no bug. Nothing is wrong in the software, for instance. But just because you didn't run the test case in the correct order, just because you couldn't find the interdependencies between them. And that is a very important topic when it comes to software testing, and solving such a problem manually or without AI help, it would be a mess. And that's why in one company, we run one solution, automatically finding the dependencies between test cases, and we reduced the failure up to 40%. Almost half of the failure, it was just because of the dependency. So you can imagine the cost. Another important aspect is like if you run a test case or test scenario on a wrong platform, where the platform can't satisfy the need, then you will get failure as well. And it's, again, a big problem of wasting resources. I will cover the last one with one case study, then you can get better overview what I'm talking about. So each test platform has a configuration, which means it can handle a set of complexity. So you have super complex test platforms and some easy test platforms, which are not very complex. So assigning the correct test case on the test platform based on the complexity is another important topic that we need to have AI, and we managed to have AI for that. So a bit more technical, so I selected two case studies that we solve at different industries, and we optimize the process. We use AI, and one is for test environment optimization, and one is for AI-based test management system. Case study 1 is an intelligent test management system, and we have good achievement for that. We managed to file a patent. We managed to publish a journal article about that. But most important thing for me, it was like achieving production grade at Ericsson for this case study. And it was very important just because from the beginning, we tried to solve super manual problem that it was meeting after meeting. But in the end, after those achievements, after proof of concept, it took, of course, 3 years for us, we managed to put it in the production environment. And that is big achievement, especially in the large company, that is not easy to change the way of working and procedures. Intelligent test management systems trying to assign a test case on the correct pipeline. I'm not sure if you are familiar with software development lifecycle, but when it comes to the testing phase, different features, different property of software need to be tested in different levels. Sometimes you need to test them every night. Sometimes you need to test the interaction between them. Sometimes you need to test them as a unit separately. And it's very important that you know where you should put them. We call them as pipeline, CI/CD pipeline, which is part of agile testing. How we do it today in most industries, like people are sitting, gathering, and it's like test scope analysis meeting. We have a test manager, we have testers, we have troubleshooters, and they talk with each other. Okay, this feature, this test case should go to pipeline A based on the things that we think and based on the experience and based on the previous project and whatever we have. If you make a wrong decision here and you add one feature on pipeline A, for instance, pipeline 1, which belongs to pipeline 2, our studies shows it took up to between 3 and 4 months to have back the test case to the test scope analysis. I'm assigning something based on my experience, human judgment can be wrong, and I'm saying, for instance, this test case should go to pipeline 1. Testers, they are scheduling, test platform is assigned, they are trying to test, but in the end, it will be, is it wrong decision and wrong pipeline? And failure after failure, and then it will be ticket created in Jira, back to the board, and again, we need to have test scope analysis, and now let's make a correct decision again. So this one is the daily task. As a good example that AI can help for optimizing the process. Why? First, large requests, especially if it's a big product. Secondly, several things need to be considered at the same time. From the customer, ISO standards, from the company, way of working, functionality and non-functionality requirement. For instance, if it's robustness, if we would like to check the capacity, security, or which part of which functionality we are testing. The definition of pipeline here is the combination of the testing level, unit integration system testing, and quality area. We merge them together, and then we define different pipelines. The task is like daily. You should sometimes analyze 100 requests and assign to the correct pipeline. Not easy, right? What we need, we have a test management database, and we do the label data, we use regression, we use historical data, and we make a correct labeling. And of course, we have still human in the loop that whenever the model says, for instance, pipeline 1 is the correct pipeline, we double check with human. But the time that we are minimizing here is from weeks to minutes. So for sitting 1 week and solving the things is like just check the results that AI provided. Do you agree or not? If you agree, let's go for execution. If not, then now we can sit and do this test scope analysis meeting. Here is the better definition of the pipelines, but please consider that is very domain dependent. In some industries, it can be, execution environment can be defined like centralized, decentralized, level of the testing can be unit integration. In some industries, they jump some of them and they have different way of defining a pipeline. But anyway, CI/CD pipeline should be considered. So in this case, that we analyze it, it was like that. And of course, we can't share all information, but I try to take it in the high level, presentable for this talk. And some information about ISO characteristic that need to be considered. So you see several things at the same time should be considered. The second one is about scheduling test platforms or test channels using AI. And that is another good solution that we managed to put in the production environment. Again, for me, is the most important and tough part. But beside of that, we filed patents, 2 patents, and we got the best paper award for the first version of the solution that we presented. And currently, they are using at Ericsson again. So it's a very good example of how AI can be used at industry in the reality. What we are trying to solve, for testing any feature, you need to have a platform running the test cases on the platform. It can, different terminology can be used. You can use test platform, test channel, test environment, test bed, test track. Again, depends on what company and what methodology you are using, but it's the same. It means execution environment that you can run, for instance, your code. I'm trying to make it simple. What you need, what is the input of that? High-level functionality of the test cases. It can be manual or it can be code. And metadata. Who are you? When you would like to do the testing, what is the duration, what is the priority, and which team will do the testing. We call it metadata here, and high-level functionality that you can say, for instance, I would love to test, in this case, in telecommunication 4G or 5G, or when it comes to autonomous vehicle, you can say this is a standard I would love to test. Very high-level information is enough. When it comes to this expert system, AI-based, it has two different components, two different modules embedded inside. First is the configuration prediction. It checks, based on the input, that high level you provided to the solution. It checks what we have today in the lab. We can have thousands of test platforms, but not necessarily all of them are in the same level, same capacity. Predicts the configuration, which means the capacity or capability of the platform. The second module checks the metadata. You send a request, and I can send another request, and the model can get hundreds of requests per day. Different priority, different starting date, different duration, or sometimes there are overlaps. And it's like the model makes the best decision using deep reinforcement learning, Q-learning table, and making the correct decision each time. That my request can be executed first, maybe just because the test platform is ready and I have a higher priority, and it will schedule your request after I'm done with testing. Next day, tomorrow, another request comes, and the model needs to make the decision again. So it might be a case that it stops my execution and makes the test platform ready for you just because you are coming with a higher priority. Of course, other aspects should be checked. For instance, can we set back the test platform in the same state that we got it? Where are we in the testing process? Maybe if we are waiting for more hours, I'm done completely with the testing. So it doesn't make sense to stop the testing, wait for 4 hours, and then the test channel will be ready for the next one. Before that, the way of working is like first come, first serve. You send a request today, even you are not ready to do the testing, but just because you send a request to the testing community, to the meeting first, you will get your test platform. Day after, I am coming with a higher priority, everything is ready, I have a tester, everything is settled, test cases are written, I'm ready to do the execution. But just because I'm coming after you, I should wait until, I don't know. So first come, first serve, compare to this one. So another good example that AI can help to make a correct optimization. And the cost saving behind that is very huge. And of course, it takes cost and time for us to deploy it and develop it. It was not an easy task. It took several years for us. But in the end, it is good just because such a decision support system is needed until you are testing something. So here is a better explanation about the hardware request as a high level, as I said. And metadata, as I said, is time, ID, duration. And the model makes the decision, prediction, using deep neural network and assigning the list of the components, and you can schedule the test cases. Same methodology in the next step can be used for building a test platform. Until now, we try to schedule the test platforms that already exist in the lab. But how about the future? Is it enough with the test platforms that we have? If the test platform never ever used by someone, what's the point to keep it in the lab? Or if we have a test platform which is overbooked by people, why we are not duplicating that test platform? The same methodology in the future it's not deployed yet, but the patent and the idea is done, can be used for getting the same level of request by the end users in advance and making a decision to keep or decommission a test platform in the lab. And a lot of cost saving behind that as well. As I said, if you are not using a test platform, if no one sent a request in the past 6 months, what's the point of keeping that? Then the model will make a decision. The level of decision making here is in the hardware component level. We have a dynamic inventory. We add, if we buy new switches, if we buy new hardware component, the database will be updated automatically. It's connected to the other team if they are ordering something. And based on this dynamic inventory, the model checks what hardware is available until when. We put the time in the hardware equipments. For instance, this switch is available right now, but is scheduled to be booked on another test platform in 3 months. Then the model has a better overview. I can gather this hardware, or this hardware is already taken, so let's order this hardware. This one will take more time for deployment just because it's not about just using the existing, it's about the ordering, it's also which supplier we should use for order the things, just because it has the ability to check the prices as well and other things. So during to the GDPR and other stuff, it will take a bit more time for deploy it and use it in the reality, but we managed to file patent the idea and publishing papers behind that. And up to 70% reduction in the overall cost in the simulation environment that we checked if we would like to go for such a model. So from the ambitions to abstractions, so the AI deployment, still we have a lot of issues. Even AI shows good results in a lot of use cases, especially at academia. It shows a lot of potential use cases, and sometimes at industry as well. But you can't go, based on my experience, to industry and say, hi, we are replacing you tomorrow with that AI model. Still, this discussion that you are in the loop, human in the loop, we need your opinion for labeling the data, checking the results, checking the decision making, still is not easy. People doesn't want to change. They would like to use the things that they did in the past 20 years. That is the big challenge, in my opinion. The second one, especially in Europe, is data privacy and security. Whatever we are coming and whatever we are presenting, always we should check against GDPR. Can we deploy it? If not, if it's against that, since we don't have any solution right now, should kill the solution. So it's like, we can't deploy it just because there's no opportunity. And integration with the legacy system. Sometimes we are providing very good solution, shows a lot of cost reduction, time reduction, even our colleagues are happy, but you can't add it on the current system that you have. This legacy is designed 20 years ago for other purposes, is not compatible with the cloud environment, is not compatible with the GPUs, and then you can't use it. So that will be another problem that we will face very soon, that some of the infrastructure needs to be changed if we would like to go for AI in industry. In the book, me and Leo, we try to summarize the challenges that, at industry especially, we might face for using AI. Forget human, forget people that they don't want to use it. But in the reality, if we have an environment that everyone is happy to go for AI and we have a good team of data scientists, but still there are 4 issues that we summarized. It can be more, but we try to merge it in 4 classes. Architecture is like if you don't have good AI strategy. If the company is like that I'm coming today with one solution, another one comes with another solution, and there's no goal. Like 5% AI solution until end of 2025. is not going to work. So such a strategy is needed, exactly like a tested strategy, is exactly like a strategy of way of working. And it's time to have such a strategy. Cybersecurity risk, if the cybersecurity part of the company is not good and mature enough to support the AI architecture, it will be failure, and it will be hard to have it. Those legacy systems, as I said, integration with cloud environment, for instance, supporting IT system. So it's very important that those basic, I mean in AI world, we will basic infrastructure, basic way of working be there before we go for any AI solution. Data, always a problem. Data management, lack of data, sometimes some companies say, oh, we have a bunch of data, but in the end, it's like even 10% of that can't be used. Inefficient, not good, and it's like inaccurate data, a lot of missing values, and we need to do oversampling, undersampling, we need to extrapolation, interpolation, and this process takes ages, and then it doesn't make sense to go for that. So it should be some strategies regarding the data. Some of the databases that we are using currently at industry should be changed by thinking that this database in 2 years will be a core of a training data for AI model. And we are not there yet. Some of the companies, they started, but generally we are not there yet. Complexity. If you are going with super complex AI solution, providing a deep neural network, architects explaining, it will be very hard for people to trust you and use the solution. On the other hand, going with the black box, that is the solution, is input that I needed, and that will be expected output. This one doesn't work neither. So a gray box, finding balance between these two might help. And when it comes to cost, which is very important, AI is expensive, of course it is. Implementation, maintenance, ROI is not always positive, especially from the beginning. Sometimes, our stage it took 2-3 years to have positive ROI, return on investment. But it's not the only cost. The data has its own cost. The security has its own cost. So it's like very expensive, and sometimes the small companies that they just started doesn't make sense for them. Not sufficient data, nothing there, and then it will be very negative ROI. And for some other industries, large industries, it makes more sense if they can work on the infrastructure and make it ready for using AI. But we ask AI, so if everything is settled and we can have AI in the future, 2030, do we need humans still in the software development life cycle? And the answer is yes. So I'm using this one whenever I'm presenting at industry, so don't worry, you're still there. So it seems that beside of the new jobs, new opportunities, new roles that AI will bring to industry, when we are thinking about traditional software development life cycle, even the AI prediction is like that, still human in the loop. Still we need to have human, especially when it comes to the safety critical systems domain, which is currently my domain, and all the research shows that manual testing or manual requirement analysis is better compared to 100% automated. But the best one is having AI as an assistant and human. So together, a safety critical system together. So that's all actually for me. And you can scan this code if you have any question or you would like to contact me and you have any idea. I would love to contact and answer the questions. Thank you.